Hello, and welcome to Math Matters. I'm Miss Ogden, and today we'll continue to learn about how we can apply what we know about rational numbers to construct and interpret circle graphs. For this lesson, you'll need paper and a pencil or something else to write with. We'll pause for a moment so you can gather those materials. Now that you're ready, let's get started. Let's get our brains ready to rock with a warm-up. For this routine, you'll take a look at the images on your screen and choose one that you think doesn't belong. Why do you think it doesn't belong? There's reasons that we can use to argue why any of them don't belong. It's all about justifying and defending your thoughts. We'll pause for a while for you to choose which one doesn't belong and jot your thinking down. If you have more time, I challenge you to select a different image and come up with a reason for why it doesn't belong. Here are just some of the reasons why each of the images might not belong. You might have thought about different ideas or had different reasons, and that's okay. Your ideas can be different. There are no right answers because there's so many ways you could think about this routine. Maybe you decided that image A doesn't belong because it's the only spinner that has 4 equal parts where each color represents 1/4 or 25% of the whole. Or because image A is the only one where the orange piece isn't the largest fractional piece of the circle. Maybe you decided that image B doesn't belong because it's the only spinner with 3 colors instead of 4. Or because the dark blue piece is larger than all of the other dark blue pieces in the other images. And it looks like it's about 1/3 or 33% of the circle. Perhaps you chose C because the orange piece in the spinner is greater than half, or 50%, and the orange piece in all the rest of the images are less than half. Or maybe you chose C because the dark blue and green pieces combined seem to be less than 1/4 or 25% of the spinner, and those pieces are smaller than they are in the rest of the images. Finally, maybe you chose D because it's the only image where the teal piece is less than 1/4 or 25%, or because half of the pieces are congruent. The dark blue and green pieces are the same shape and size. For today's learning, we'll have 1 math goal and 2 portrait of a graduate goals. You'll probably recognize these from the last few days. Our math goal is, I am learning to apply my understanding of rational numbers to construct and interpret circle graphs. By the end of today's lesson, I hope that you'll be able to interpret a circle graph using your understanding of fractions, decimals, and percents, and that you'll be able to create your own circle graph to represent fraction, decimal, and percent values. Mathematicians are persistent, so our portrait of a graduate goals will continue to focus on being goal-directed and resilient. We want to keep working on these skills in and out of school until they eventually become a habit of mind. The first is, I persevere through difficult tasks and situations. You keep trying and don't give up, even when you get stuck. The second is, I learn from my mistakes and ask for help and feedback to improve my work. You know that we can learn a lot from our mistakes, and you aren't afraid to ask for help or feedback along the way. Let's take a moment to review the process of statistics. Statistics is the process in which mathematicians formulate questions, collect data, analyze that data, and interpret the results. Mathematicians always have a purpose for collecting data.
and the questions we ask are usually about things we want to learn more about. And the graphs we create always tell a story. The first step is to formulate a question. We asked 2 6th grade classes to tell us their favorite musicians. Here were the choices: Drake, Beyonce, Justin Bieber, The Weeknd, and Post Malone. Our next step was to collect the data. We collected data from 2 6th grade classes, each with 24 students. Let's take a look at their results. Here's the data from Miss Gilmore's class. If we add up all of the students, we can see that we have a total of 24. And here's the data from Mrs. Mendelson's class. Again, if we add up all the students, we have a total of 24. Now that we've collected our data, we're almost ready to construct a circle graph. But first, we need to analyze that data so we can understand the numbers from each class and how they're a part of the whole. Let's analyze Miss Gilmore's class's data first. We know that 6 students voted for Drake, and we can represent that as the fraction 6/24. We can simplify that by dividing by 6/6, because that's the same as 1 whole, and we'll get 1/4. I remember that 1/4 is equivalent to 25/100ths, or 25%. So we'll represent Drake's 1/4, or 25% of the data, in the circle graph with a red piece to make sure it matches the key below. 12 students voted for Beyonce, which is 12/24 as a fraction. You might immediately recognize that 12 is half of 24, so Beyonce's votes represent half of Miss Gilmore's class data. And we know that that's equivalent to 50/100ths, or 50%. We'll represent Beyonce's 50% of the class data with a yellow piece. Next, we can see that no one voted for Justin Bieber. Since he's got 0 votes, we don't need to represent him in our circle graph. 3 students voted for The Weeknd, which we can represent as 3/24. We can simplify that by dividing by 3/3 to get 1/8. And we can use reasoning to figure out the equivalent decimal and percent. I know that 1/8 is half of 1/4, so we can think about what half of 25/100ths, or 25% would be. Half of 25 is 12.5, so half of 25/100ths would be 125 thousandths, or 12.5%. Post Malone had the same number of votes as The Weeknd, so his values will be equivalent. We'll represent The Weeknd's 12.5% and Post Malone's 12.5% of the votes with blue and purple pieces. Just like all circle graphs, if we add up all the percentages, we're going to get a sum of 100%. Now let's dig into the data from Miss Mendelson's class. 12 students, or 12/24 of her students, voted for Drake. We know that 12 is half of 24, so Drake's votes are equivalent to 1/2, 50/100ths, or 50%. We'll represent Drake's half, or 50%, of the data in red. 3 students voted for Beyonce, which we can represent as 3/24. We can simplify by dividing by 3/3 to get 1/8. And again, we can use reasoning to figure out the equivalent decimal or percent. 1/8 is half of 1/4. So we can think about what half of 25/100ths, or 25%, would be. Half of 25 is 12 5/10. So half of 25/100ths would be 125 thousandths, or 12 5/10%. Justin Bieber, The Weeknd, and Post Malone had the same number of votes as Beyonce, so all of those values will be equivalent. We'll represent their 12.5% in yellow, green, blue, and purple pieces. Again, when we add all the percentages, we'll get a sum of 100%.
Let's take a moment to compare each class's data. Take some time to think about how these circle graphs are alike and different. Jot down any similarities or differences that you might notice. One way that you might have noticed that they're alike is that they both represent 100%. If we add up all the percentages in each graph, we'll get 100%. Another similarity you might have noticed is that The Weeknd and Post Malone both got 12.5% of the votes in each class, or that both circle graphs have one artist that got half of the votes. One difference you might have noticed is that one musician got half of the votes in each class, Beyonce in Miss Gilmore's class, and Drake in Miss Mendelson's. Another difference you might have noticed is that Mrs. Mendelson's class represents all 5 musicians, while Miss Gilmore's only represents 4, because no one voted for Justin Bieber. Or maybe you noticed that 25% of the students voted for The Weeknd and Post Malone in Miss Gilmore's class, and any combination of 2 musicians, including Beyonce, Justin Bieber, The Weeknd, or Post Malone, represent 25% of the vote in Mrs. Mendelson's class. Maybe you notice other similarities and differences that I didn't mention, and that's fine too. Now let's take some time to analyze the data compiled from both classes. Use the chart to determine the fraction, decimal, and percent of each musician's votes. You can use reasoning strategies like we did in previous slides, or your calculator. Take some time to create the chart on your paper, and then find the fraction, decimal, and percent values for each musician. Once you've found them, go ahead and construct your own circle graph on your paper. We'll pause for about a minute for you to do your work. I'm going to use a mix of reasoning strategies and my calculator to figure out these values. And I'll start with Drake because he had the most votes, and those votes are represented in the red section of the circle. 18 students out of 48 voted for Drake. We can simplify this by dividing by 6/6, which is the same as 1 whole, and we'll get 3/8. I remember that 1/8 is equivalent to 125 thousandths. And if I triple that or multiply by 3, I'll get 375 thousandths. And that's equivalent to 37.5%. I'll label the red section with Drake's 37.5% of the votes. I'll move on to Beyonce next because she had less votes than Drake, but more than the others. 15 out of 48 students voted for Beyonce. We can simplify by dividing by 3/3, and we'll get 5/16. This fraction is a little trickier for me, so I'm going to use my calculator to find the decimal equivalent. When I divide 5 by 16, I get 3,125 10,000ths, which is equivalent to 31 2500ths%. So I'll represent the yellow section of the circle with Beyonce's votes. I'm going to skip over Justin Bieber and focus on The Weeknd next because I know his values will be equivalent to Post Malone's. Then I'll use that to figure out Justin Bieber's. The Weeknd got 6 out of 48 votes. To simplify, we'll divide by 6/6 and get 1/8. And I know that that's equivalent to 125 thousandths, or 12.5%. So we'll represent The Weeknd's 12.5% in the blue section. We know that Post Malone is going to have the same values as The Weeknd, so we'll represent his 12.5% in the purple section of the circle graph. Now let's go back to Justin Bieber. He got 3 votes, which is the same as 3 out of 48. That's half of what Post Malone and The Weeknd got. So that means I can use their values and cut them in half to figure out Justin Bieber's. I know that 1/16 is half of 1/8, and I can prove that by dividing 3/48 by 3/3. Next, I'll half the 12.5% of The Weeknd and Post Malone's votes, and that'll give me 6 25/100%. So the decimal value must be 625 10,000ths. We'll represent Justin Bieber's votes with 6 25/100% in the green section of our circle graph. Another way we could have figured that out would have been to work backwards from 1 whole or 100%. We could have found the sum of all the other musicians and then subtracted from 100% or 1 whole. We can check our work by adding up all the values. The sum of all the student votes will be 48. The sum of all the fractions should be 48/48, which is equivalent to 1 whole. And that's equivalent, adding all of the decimals together will also give us 1 whole. And finally, when we add all the percentages together, we get 100%. Let's dig a little deeper to make even more sense of this data. Identify 2 true statements about the circle graph. Write down your thinking to justify and defend why you believe each statement is true or false. A, the total number of students that chose Beyonce or Justin Bieber is equivalent to the number of students who chose Drake. B, 1/3 of students chose The Weeknd or Justin Bieber as their favorite musician. C, the total number of students that chose Post Malone or Drake represent more than half the data. D, 5 times as many students voted for Beyonce than Justin Bieber. Take a few moments to finish justifying and defending your thinking.
Let's zoom in on each statement and think through why it's true or false. A says that the total number of students that chose Beyonce or Justin Bieber is equivalent to the number of students who chose Drake. Well, I see that this statement says Beyonce or Justin Bieber. So that must mean that I need to combine their amounts. And I can see that when I add those together, the sum will be 37.5%. So this statement must be true. B says that 1/3 of students chose The Weeknd or Justin Bieber as their favorite musician. To figure this out, I'll need to combine the percentage of votes for The Weeknd and Justin Bieber. When I add them together, I can see that I'll get 18 75/100%. I know that 1/3 is equivalent to 33%, and 18 75/100% is less than 33%. So this statement is false. C says that the total number of students that chose Post Malone or Drake represent more than half the data. I see that word "or" again, which means I'll need to combine the percentage of votes for Post Malone and Drake. And when I add them together, I get 50%. I know that 50% is equivalent to half, so this statement must be false because it says that Post Malone and Drake will represent more than half the data and their votes represent exactly 50%. Finally, D says 5 times as many students voted for Beyonce than Justin Bieber. To figure this out, I'll need to determine if the votes for Beyonce are 5 times the amount of votes for Justin Bieber. If I multiply 6 and 25/100% times 5, I see that I'll get a product of 31 and 25/100%, which means that this statement is true.
I challenge you to create 2 true statements on your own. Make sure you justify and defend why those statements are true or false. Feel free to share your statements with your classmates or teachers. Feel free to do this during your independent student work time.
Mathematicians periodically reflect on what they've learned throughout the problem-solving process. So let's take a moment to do that from the lens of Portrait of a Graduate. Remember, we're trying to develop a couple of habits of mind as goal-directed and resilient individuals: perseverance and the desire to learn from our mistakes. How do you feel about the math you've done today? Did you find any part of it challenging? And if so, how did you persevere or keep going even when things got hard? What did perseverance look and sound like? Did you make any mistakes today? If so, what might be something that you learned? What does learning from your mistakes look and sound like? Take a moment to jot down your ideas about what perseverance and learning from your mistakes look and sound like on your paper. In today's episode of Math Matters, we continued learning about how we can apply what we know about rational numbers to construct and interpret circle graphs. As you reflect on our math goal, how do you feel about your ability to read and interpret circle graphs? Do you feel like you could construct your own circle graph? Give a thumbs up if you've got it, a thumb in the middle if you're still practicing, or a thumbs down if you feel like you need help from a teacher or someone at home. I encourage you to share any questions you might have had today with your teachers. I'm Miss Ogden. I hope you have a great day and keep on counting.